In the last section, we installed the web worker threads library, and we're going to start wiring it up inside this video. As a quick reminder, just remember that this really is some very experimental stuff that I'm just showing you in case you are curious for whatever reason. But in general, my personal opinion is to make use of cluster mode, and in particular the PM2 module, if you're concerned about getting some level of better concurrency inside of your Node application. Let's first get started by taking a quick look at a diagram that's going to explain how this worker threads library works, and then we'll actually implement it inside of our Express application. Okay, so this is the general idea of what's going on. At the top of this diagram, we have the thread that our application is running in. So essentially, this represents the event loop right here. And then on the bottom is the thread that will be created by this new worker object that is created by the web worker threads library. So this is a separate thread that is also running on our computer. Because it's in a separate thread, that means it can do a lot of blocking work or a lot of heavy calculations and not necessarily block any of the code that is being executed inside of our event loop. Before we actually make use of this library, one quick thing that I want to remind you of right now. Remember that a lot of code inside of the Node.js library, as we've already seen, already makes use of the libuv thread pool. So if you're thinking that we're going to be running like that hash function really quickly by making use of this thread right here, well, that's not entirely true, because our pbkdf2 function already runs inside of a separate thread to make sure that it does not block our event loop. So my personal opinion here is that this web worker stuff, not quite as useful, I would say. You know, I don't want to be like 100% saying don't use this, but just keep that in mind that sometimes you are already using code that is being executed in a separate thread anyways. So really you only want to use this thing if you have some really heavy duty business logic of your own that you want to execute off of the event loop thread. Now to communicate with this separate thread over here, we don't get to have like very direct means of conversation per se with the work that's being done in this worker. So in other words, we cannot freely reference variables inside of the worker from our application. We have to do some very direct means of conversation by using this post message and on message system. This worker interface box right here represents the worker object that you and I are going to create inside of our server. The worker interface then creates this worker thread, and we communicate back and forth between the two by using post message and on message. OnMessage is a property that we are going to assign a function to. That function will then be invoked anytime we call postMessage on the opposing side. In other words, if you and I call postMessage from our server, it's going to invoke the function assigned to OnMessage inside the worker. And then the opposite is true as well. So if we call postMessage over here, it'll invoke a function assigned to the OnMessage property inside of our worker interface back over inside of our application. Now, this definitely is turning into a little bit of a tongue-tie kind of deal here. So let's actually write out some code and get a better idea of how this thing is put together. All right. Now, I'm going to, again, just reuse our index.js file here. So if you want to back up any of the code inside of here, feel free to make a copy of the contents or whatever you wish to do. At the top, I'm going to first get started by requiring in that web worker threads library. So I'll say const worker equals require web worker threads, and then we want one specific property off this library called .worker, like so. Then down inside of my get route handler, I'm going to remove the pbkdf2 function. So like I said just a moment ago, this pbkdf2 function is already using our existing thread pool. So if we used this thing to somehow run run that inside of this worker we're going to create, kind of defeats the purpose because it's already being created in a separate thread anyways. So we're going to again have to come up with some different type of worker function to simulate doing some work inside of our app. So I'm going to delete that thing, and in its place I'm going to create a new worker object. So this is going to be like this worker interface right here. So I'm going to say const worker equals new worker, and I'm going to pass a function into this thing. Now, one thing that's very important here, when we pass in this function, we cannot freely make access to variables declared outside of it. So if we have something out here like const a equals 1, when we declare this function right here, I cannot do a like console log of a and then expect if I update the value of a or something like that to see it reflected inside the function. The function that we put inside of here is essentially going to get stringified and thrown out to a totally separate area of our computer. And so we don't get to freely, easily access variables in the closure scope between these two. So just keep that in mind. That's why we're using that entire post message and on message setup anyways. Okay, so this gives us our worker. We're going to add some logic inside this function in just a minute. But first, let's make use of the post message and on message properties on the worker interface that we just created. So on this worker interface right here, we're going to define the on message property and assign it a function. So I'm going to say worker.onMessage equals function, like so. Now whenever our worker sends a message back to our application, this function right here will be called. One thing I want to point out to you is that I did not make a typo here with the lowercase m. This is on lowercase m message, like so. Then underneath this, we can send a message into this worker. So we can like push some data over into that running thread by calling worker.postMessage, like so. So we've now created the interface. We've said what should happen inside of our application whenever that thread posts a message back to us. And we have also called post message inside of our application. So this function call right here is represented by this box right here. And this on message property being assigned a function right here represents this box right here. So we've defined our application side interface for this worker thread. Now we're going to move into the worker itself and define the post message and on message functions over there. So we're now going to define what our worker should do when it gets sent some amount of data. So now inside of the worker right here, I'm going to first define this dot on message. And I'm going to assign that a function as well. Now, one thing I want you to take very special note of right now is that I'm using keyword functions all over the place right now, and I'm not using arrow functions. I'm using keyword function because notice how I'm referencing this dot on message. This inside of this function right here is equal to the thread itself, like not necessarily the operating system thread, but an object that represents the thread. If I used an arrow function right here, then inside the function, this would refer to the context of our route handler, which is definitely not what we want. So I am using the function keyword very much on purpose right now. After defining that on message property, I'm then going to call post, I want to call this one inside the on message, post message, like so. So we've now put together the communication interface for the worker itself. So this on message equals function right here is represented by this box right here. It's the function we run when our application calls post message. And then inside of that function, you and I are calling post message right here. That represents this box right here. So when we call post message right there, it communicates something from our worker thread back up to our application. I know all this like duplicate post message on message stuff gets confusing, and that's just why I'm taking a little bit of time to make sure it's very clearly described. So now inside the body of this function, like right here, this area right here, this is what will be invoked when our application calls post message. So this is our opportunity right here to do some amount of work over inside that other thread. So some computationally expensive operation, let that thread execute it. And then after that work is done, we can communicate the result back over to our application by calling post message. So let's kind of simulate doing a little bit of work inside of here. We're going to do a very simple little work function here. We're going to, rather than doing like that previous while loop where we wait for some time to pass, we're instead going to make a counter function that counts up to a very high number. And then we're going to return the result of that back over to our running application through post message. So I'm going to say let counter equals 0. And then we'll define a while loop that's going to run as long as counter is less than 1 times 10 to the 9th. So 1e9 right here is equivalent to like 10 followed by 9 nines, like so. That's what the 1e9 represents. And then while that's true, we're going to increment our counter by 1. Again, this is meant to just simulate some amount of work being done inside of our worker thread that eventually leaves us with some actual value that we might want to communicate back over to our side of the application. So after running all this work and ending up with this super high value for counter, we're going to communicate that result back over to our side of the application through post message. So I'm going to pass it into counter like so. When we call post message with counter right here, we're essentially saying take the counter that just got calculated inside of our worker, pass in a post message, and that gets communicated back over to our application, specifically into the on message callback. So that's this callback right here. So I think for right now, let's just put down about like my counter, and we'll console log the result and just see what happens. So let's take a quick pause right now. We'll come back in the next video and we'll test out this code and see how we're doing.